In this video, we're going to create a simple part in BobCAD from beginning to end for the mill. This tutorial can also be used for routers, plasmas, lasers, and water jets. Now, what we're going to do is create a circular part that has a 6-inch radius, a few notches in the side, a pocket, and some tapped holes as well. So let's go ahead and start. So to do this, we'll start with a circle. So we'll come to arc and then coordinates. We'll place the center X, Y, and Z at 0, and we'll give this a 6-inch radius. Actually a 3-inch radius, so that we have a 6-inch overall diameter. When we click in the next box, you'll notice that the preview updates on the screen. Every change that you make in these dialogues will update the preview. Let's go ahead and start with an angle of 0 and end with 360 degrees. That builds a full circle. We'll go ahead and click OK. You'll notice that the color of the preview has changed because the item's actually in the screen now once we click OK. We'll go ahead and click Cancel, and now we have our circle on the screen. Now we're going to use some rectangles to cut notches into the side of the circle. So to do this, we'll come to Other, and then Rectangle. And let's go ahead and make a 1 by 1 rectangle, and we'll give the corner a radius of 1/16 of an inch, or 0.0625. And now we'll make the origin. We're going to use Enter, and what we'll do is we'll move the origin over an X 3 inches. And you'll see when you click in the Y box or in the next dialog that the rectangle moves over and shows where it's going to be placed. We'll go ahead and click OK, and that places the rectangle on the screen. That's 1 inch by 1 inch with a 0.0625 corner radius at X3 and Y0. We'll go ahead and click Cancel. Now we'll want to trim these extra entities away to make this an actual notch. So we'll go to Utilities, Trim and Extend, and we'll choose Quick Trim. Quick Trim will just delete the items that you click on. So let's go ahead and click on the inside of this circle, or the inside of the rectangle, and we'll just click on each item that we want to trim away so that we're left with a notch. Now, let's take this notch and place it every 90 degrees. So what we'll do is we'll copy these items that are already here. To do this, we'll cancel out a Quick Trim, then go to Utilities, and we'll choose Rotate. We'll select the geometry that we're going to rotate, which are these lines. We'll just simply drag a window. Then we'll right-click and left-click OK to confirm our selection. Once we've done that, we can fill out the information about how we want to rotate it. So since we're doing a 2D rotate, we'll just pivot it right around the Z axis. So the Z will make this 90 degrees. And we're going to activate the copy box here by clicking on Copy. And what we'll do is we'll create 3 copies, which will give us a total of 3 entities going around. Now, since the origin's set to pick, it's waiting for me to pick somewhere on the screen, so I don't have a preview because it doesn't know where it's going to rotate to. Let's go ahead and change the origin to Enter. Once we've done this, we could see the preview because it knows where to rotate around, which is, in this case, X, Y, and Z0, and it's rotating every 90 degrees, and it's going to make 3 copies. So we'll go ahead and click OK, and then we'll cancel. Let's go ahead and trim the rest of these out. We'll go to Utilities, Trim Extend, and then we'll choose Quick Trim. We'll click on the items that we want to trim, and then right-click and choose Cancel. Now we have the outline for our shape. Now let's go ahead and add the pocket. To do this, we'll use another rectangle. We'll click on Other, Rectangle, and we're going to move the origin over to 0 and X since it saved our last setting. And let's make this pocket 2.5 inches by 2.5 inches. and we'll use a quarter radius of 0.25. And this looks good, so we'll click OK and then cancel. Now the last thing to add are going to be the tapped holes. We'll use a hole pattern for this. So we'll click on Other, Hole Pattern. We're going to change the hole pattern from circular to a grid type pattern. And we'll make the pattern 4 inches by 4 inches across. And we'll make our hole diameter 0.25. And we'll place just 2 holes across an X and 2 up and down Y. So that gives us a pattern of 4 holes total. We'll change our origin to work off the center at X, Y, Z, 0. Now these are a little close to the edge. Let's go ahead and move them in. So we'll change our 4 by 4 for width and height to 3.5 by 3.5. That looks a little bit better. Now it looks good. We'll go ahead and click OK and then cancel. Let's go ahead and break these edges and place a fillet on all the sharp corners. We'll come to Arc and then Fillet. Let's use a 1/8 corner radius, 0.125. And we'll leave Trim activated so it will trim the lines as we do the fillet. Now we'll just click the first line that we want to fillet and move the mouse over to the second, and you'll see that it places the radius on the corner. And we'll go ahead and continue choosing all the corners until we have what we want on the screen. So we just click the first line, then click the second, and continue doing that around the part. And you'll see when you hover over another line, it gives a preview of what the result will be. Okay, now we'll go ahead and click cancel, and our part's complete. Let's go ahead and start programming the part. To program any part within BobCAD, we come to the CAM tree, which is right here on the Data CAM Tree Manager. And here we have our CAM part, our milling stock, and a turning stock. Let's go ahead and choose the machine that we're going to create this program for. So we'll click the plus symbol next to CAM part, right click on Milling Tools. We'll come to our part, and then current settings. Now this brings up the machine or milling settings. Now if you're cutting on a plasma, laser, or water jet, you will have set up a machine that will be for your plasma, laser, or water jet, and the type of machining will be selected down here. Now since we're using milling, we're going to go ahead and leave this on milling. And earlier we had created a Fanuc O machine, so we'll go ahead and keep that selection. And this is for a 3-axis cut. And we've already set up our spindle feeds and our feed rates, so we should be good at this point. We'll go ahead and choose OK. Now this just selected which post processor is going to be used, and also several other options for this program. And that can be changed at any time after programming as well, and then the G-code will update for that machine. The first thing to do when programming is to define the stock. So we'll right-click Milling Stock, choose our Stock Wizard, and we'll pick what type of stock we're going to machine this out of. Let's go ahead and use cylindrical. Let's say we're cutting this out of a piece of round stock. We'll choose Next, and let's go ahead and set up the size. So we'll enter the diameter. We'll say that this is 6-inch stock, and it's 1 inch thick, and you'll see that the stock generates on the screen. We'll go ahead and choose OK. Now that the stock's set up, we can come to our CAM tree and add a toolpath. If we click the plus symbol next to milling stock, we'll see that we have a type of material selected. Now that's going to change how the feeds and speeds are automatically calculated. Let's say that this part's being made out of aluminum. We'll right click on our material here, which is right now set to carbon steel, and we'll choose Edit. Let's go to our aluminum category, and let's go ahead and pick an aluminum type. We'll come down here and pick a wrought aluminum alloy. Whatever material you select should just match the material that you're cutting. For this example, you can choose any material. We'll go ahead and choose OK. Now we've changed our material, which is going to update the feeds and speeds that get calculated. You can also come back and edit the material at any point and then recompute your toolpaths. Here's our machine setup. The machine setup by default was set to the origin of the part. Now if we want to change where that machine setup occurs, you can right click on machine setup and go to edit. And this will put us back into a portion of the stock wizard for changing the machine setup. You can change the origin to enter its origin, and you can update its placement. Or in this case, we're going to leave it at 0, 0. We'll choose OK. Let's go ahead and add some profile cuts for cutting out these notches. We'll do one right now just to show as an example. I'm going to zoom out a little bit, so I'm going to click on the screen and use my middle mouse button wheel to zoom out, just so that we get a better view of the overall part. We'll come to our machine setup, right click, and this gives us access to the features: drilling, 2-axis, and 3-axis milling. Let's go ahead and choose a 2-axis cut, and then profile. Now if you're using this for a laser, plasma, or water jet, profile will be your only option in here. We'll go ahead and choose next. We'll select our geometry, so we'll click on select geometry, and we'll pick what we want to cut. In that case, that would be this arc, and then these lines coming through. Now you can click on them individually, or you can also click on the first line, then hold shift and click on the last line, and that will chain select the items. Once we have our selection, we'll right click and left click OK. Then we get a preview of the shape that's going to be cut, or shapes that are going to be cut. We'll choose next and just follow through the wizard, setting everything up where we want it to be placed. Now this is a 2D part that was drawn right at 0, so the top part is 0. You can also choose pick top of part to pick the location of the top of part from the drawing, but 0 is where we want it in this case. Our rapid plane is the distance that the tool will travel above the 0 point in a rapid when it moves from location to location. We'll go ahead and choose next. Work offset is which work offset you use on the machine. If you do not use the work offsets on your machine, you'll always use work offset number 1. In the case that you do use work offsets, these numbers will correspond to your G54, G55, and so on. They'll correspond with the G code for the work offset that you set up on your machine. 1 is usually G54. Contour ramping allows you to ramp into the part instead of doing a straight plunge cut. Let's go ahead in this case just leave this set to arc moves. When you contour a ramp, you get options for line or arc moves. If your machine can do simultaneous 3-axis motion, arc moves is always the better choice. Line moves are for machines that do not handle or support full 3D cutting. We'll choose next. Now, this is where we select our tool. Let's say we want to cut this out with a 1/4-inch tool. We can just update that number on the fly here, and that will add this tool to the database if it's not present, or select it from the database if it is. Now, if you want to add a tool to the library at this point, you can. You come to your tool crib, and we can see it's already been added to the tool crib, but let's say that we want to use another tool and we want to add it to the available crib. We'll add from tool library, and then we come into our tool library, and let's say that we want to cut the next pass with a 3/8 flat end mill, so we'll go ahead and add that into our tool crib. Now this tool crib has two cutters available in it, the 1/4" cutter that we had just added here, and the 3/8 cutter that we had selected from our database. We'll go ahead and choose OK. We'll click on our 1/4" diameter because that's the tool that we want to use. Choose OK. Now we'll choose Next. Now our patterns allows us to either cut standardly, contour a ramp, which will do a helical cut that we were just discussing, or side rough or step into the part. Let's go ahead and do standard cutting for right now. Now our system compensation allows the software to offset the cuts itself. The machine compensation uses the machine's G41, G42 commands. So if you want to use cutter compensation at the controller, you'll select machine compensation. In this case, we're going to go ahead and use system compensation, and we'll cut to the left. We'll choose Next. Side allowance is the material that we want to leave for a finish pass. If we leave the side and bottom allowance set to 0, and set our finish tool as 0, then we'll only get a single pass or a rough cut. You can use roughing for finish passes. Think of it this way: Tool 1 and Tool 2 are your rough and finish. You may only want to cut with one tool, or you may want to come back and cut with two tools. The features will automatically handle for two-tool cutting. So we'll go ahead and use side allowance. Let's put 0.02 or 20 thousandths for our side allowance. We'll leave 0 on the bottom. Our depth, let's go ahead and set the depth to 1 inch. You can also pick the bottom if you had a 3D or 3D wireframe. We'll use multiple steps, and we'll cut 0.25 or 1/4 inch per pass at even depths, and you'll see it calculates the total number of cuts. We'll choose Next again, and we'll set up our lead in, lead out. In this case, we're going to go ahead and plunge, and we'll do a parallel lead in, lead out. So what we'll do is we'll run parallel to the lines that we had started cutting on. We'll make the length 1/2 inch. Now, it's very important that when using cutter compensation at the machine, the G41, G42 codes that we could select in an earlier box, you must use a lead in, lead out for cutter comp to be initialized. If you do not use a lead in, lead out, cutter comp will not be initialized. This is required for cutter comp to work on the machine, so we also require it within BobCAD. We'll leave our lead out the same as the lead in, and we'll choose Next. Corner types for internal and external corners can either do a G2, G3, or pivot around the corners, or give sharp G1 motion. There's also several options for looping and creating triangles and bisect lines. In this case, let's just go ahead and use sharp. We'll choose Next. Now we'll select our finish tool. Let's go ahead and go to our tool crib and select the 3/8 tool that we had loaded in. We'll choose OK. And I'll enter the diameter as 0.375, and you'll see it will also find the tool in that manner from the tool crib that's set up. Let's look at the tool page for just a moment. You'll see here is the machining data, which allows you to pick your tool number if you want to override the tool number, and also your height and diameter offset, which can be overridden at this point. By default, BobCAD will use the same diameter offset and height offset for the tool that the tool number is. If you override your offsets, you can change that. You also get your options for how the coolant is output, if it's flood, mist, air, oil, so on. We'll leave this set to flood. The feeds and speeds for each tool can be overridden. If we uncheck Use System Feeds and Speeds, you can manually enter your feeds and speeds in here. If you leave Use System Feeds and Speeds checked, it looks back at the material and then automatically calculates these values. Now we'll go ahead and choose to compute the toolpath, so we'll click on Compute. Now I could see the toolpath on the screen, and I'm going to rotate this. So I'm going to hold the Control key and the right mouse button and rotate this. We could see our toolpath stepping down. But I can see that the toolpath is on the wrong side of this line. Let's go ahead and change the direction that it cuts. We know that we're cutting to the left, so we can assume that the direction is going counterclockwise. Let's go ahead and make this go clockwise. So we'll right-click on our start point and choose Reverse Direction. And you'll see it, some little arrows generate that show the direction. Once we've done this, we'll right-click and left-click OK to confirm, and then right-click on Profile and compute the toolpath. Let me click on the View All. Now we can see that we've changed the direction that the toolpath is cutting and also the side. Now the lead in, lead out that I chose, parallel, doesn't look too good. Let's go ahead and look at how to update or change that. I used parallel to this arc or parallel to the first cut. Let's use a right angle lead. To edit a toolpath, go back to the toolpath name in the CAM tree. Right click and go to Edit. Let's jump right down to our leads. Let's change this to right angle. We'll compute again. Now we can see the tool will come in away from the part, plunge down, come in, and then create the cuts. I can see that there is both a rough and a finish pass in here. Let's go ahead and just add some geometry to this selection instead of creating individual toolpaths for each cut. We'll right click on Geometry, left click Reselect, and we can see what's been selected turns red. Let's go ahead and add these shapes. So we'll click the first line and then shift click the last one and do the same for each side. Now that they're all selected, we'll right click and left click OK and then recompute our toolpath. Now I could see my directions changed here and the other ones are okay. Let's go ahead and straighten that out. We'll right click on our start point and we'll modify, and you can also change where the start point location is on cuts. Here I could see the small arrows. Let's zoom in again. Start here and cut in this direction. Let's go ahead and change where the start point is. So we'll click the other side. There we go. Now the direction's reversed. Zoom out. Now we can see all of our directions are going clockwise around the part. So we'll right click and left click OK to confirm, zoom out, and then recompute the toolpath. So that's how to modify a toolpath as well. Now that we have all of our profile cuts in, let's look at adding additional toolpaths. The steps should start to seem familiar at this point, as these will be the same steps for adding any and every toolpath within the milling system. So let's add a pocket. We'll right click our machine setup, go to Mill to Access, we'll choose Pocketing. We'll select Next, select our geometry, and we want to pick this inside shape. I'll hold Shift to do a chain selection and click on one of these lines. It'll select the entire profile. We'll right click and left click OK to confirm. Now we can see our preview. We'll choose Next. Our rapid plane and top of part are already set, so we'll choose Next again. We'll continue using Work Offset 1. Now let's go ahead and change this to our 1/4 inch tool. We'll place 0.25 for the diameter. Choose Next. We can choose to zigzag cut, offset from the outside in, or offset from the inside out. We'll choose that. We'll climb mill, and we'll do a 45% step over with the tool. We'll choose Next. Our side allowance will leave 50 thousandths for a finish pass to come back and clean up the edge. And our total depth, let's go ahead and make that 0.5. And we'll cut that again in multiple steps at 1/4 inch per pass. We'll choose Next. Our material entry or leads allows us to plunge, ramp, or spiral into the part. Let's leave this set to plunge. We'll choose Next. Now for the finish, let's go ahead and use that 3/8 tool, 0.375. We'll choose Next, and we'll allow this to use the system compensation. Choose Next again. And for the lead in, lead out for the finish tool, let's use a circular lead in, lead out with a 1/4 inch corner radius. And we'll choose Compute. Now we can see our pocket's been generated as well with the step downs. The last thing to add are the tapped holes. So to do this, we'll do the same thing. We'll come to our machine setup, right click, we'll choose Drill. Let's choose Tap. Next, select the geometry. We'll pick our hole pattern. Then right click, left click OK. And we'll choose our thread type, in this case a 1/4-20. The holes are a 1/4 inch diameter, and let's make the depth 1 inch. And check the box that says Through Hole. This will help the software set up the rest of the feature. The machining order allows you to choose the order that you pick or optimized by the software. In this case, we'll leave it optimized. We'll choose Next. We have our rapid plane and our top of part. We'll leave those settings. And then we also get an option, because this is a drilling operation, to use a chamfer. Let's go ahead and not use the chamfer. We'll just tap the holes. We'll choose Next. Our work offsets. Now in here on the tap, it's already set up because we chose the 1/4-20. So we'll choose Next again. Our effective depth is 1 inch, and the overall depth is automatically calculated based off the number of ineffective threads that was set up in the tool database. We're using a right-hand tap, and we'll compute. And that gives us the tapped holes. Now that we have our part programmed, let's go ahead and take a look at posting code and creating the simulation. To post code to send to the machine, simply come to Milling Tools, right-click, and choose Post. This will generate a preview of the program. If we want to save this program, we right-click Milling Tools and choose Post and Save. And then you could save where the file location will go. For simulation, right-click on milling stock and left-click Simulate. That'll launch the simulation. In the simulation, I could see the stock and the toolpath by default. We'll go ahead and press play to start the simulation. And that concludes this tutorial.